How to build a Blackgates Sweet Pea 5-inch gauge locomotive, part 13. A close look at the cylinders which need attention. There are two ways to fix this problem. The second method is the one that I'm going to use. I'm sure that some viewers may be wondering why I'm using pre-machined parts in this build. For two reasons. It simultaneously shows how to build a Sweet Pea locomotive, and in this episode it shows how to repair previous bad workmanship, which is very common. This is one of the cylinders and it's a bit of a mess, yet the cylinder itself is very well machined. It is dimensionally accurate and the cylinder bores are like glass, very smooth indeed. I really am beginning to think that more than one person has worked on this engine, because the machining of the slots in the port face are diabolical. This clip shows the complete set, the two cylinders complete with covers, the steam chests, the steam chest covers, and even the valves, and as you can see, they're very well made. Except, as I've previously shown, the milling of the ports is a mess. It's been done wrong in so many ways. It's never a good idea in the home workshop to use a milling cutter which is at the finished size that you want it to be, because if it wanders, instantly the port is oversized. Here I'm using a felt tip pen to illustrate some of the bad bits. The chunk out of the top left hand corner in this image really doesn't matter, but the steam ports are very below standard. You'll see that the marking out is quite good, it's much better than mine. If you look at the shape of the exhaust ports, it's obvious that the cutters were exactly the same size as the slots they were designed to cut. It's a mess, and this is a good cylinder. Now to move on to one that is even worse. This went spectacularly wrong. There's a big chunk cut out of the face where the slide valve slides, and this is unacceptable. I could machine the cylinder's port face down a little bit to get through this damage, but then I would still have the mess of the exhaust port. I could of course easily machine a couple more cylinders, but I don't want to do that. Here is potential fix number 1. I could reshape the ports quite easily using JB Weld, which is really good stuff, but I'm not sure whether this would work over time owing to the temperature and the contraction and expansion of the parent metal of the cylinder. JB Weld make a high heat 2-pack epoxy putty. Here's a pack showing the temperatures. I think this would probably work, but it's just a bit of a bodge. I would like to do the job properly. Here's the epoxy putty, you just cut it off, mix it in your hands, and then use it like putty. In this, which is an enlarged image, you can clearly see what a mess the exhaust port is. This is going to affect the timing of the slide valve. You can occasionally get problems with port faces being scored, and in this case what you would have to do is remove the cylinders from the locomotive to remachine the port face. This of course takes quite a long time, and that's something we're all running out of. The repair method that I'm going to use on this locomotive is very well established. It's the same principle that's used on steam pumps. The port face is a separate machine plate that sits over pre-machined grooves, and that seems to work perfectly, so I think I'll use the same principle to repair this job. I phoned Blackgates Engineering to order some gauge plate, but unfortunately it's not in the size that I require. Instead I'm going to make the new port face plate using mild steel, which will be perfectly fine. The plate needs to be accurately cut to size, and here I'm applying some marking out blue. In this case the blue is called steel blue layout fluid. This particular bottle was sent to me by a kind viewer some years ago. After applying the marking out blue, I gave it a bit of time to dry. Once it was dry, I scribed a line on it and then I put it in the bandsaw's vise. It made a really good noise as the blade touched the metal, so I left it in. Even though this is a thin piece of metal, it still took quite a while to cut it, but after a while I had the first plate. The vise on this bandsaw is not perfect and it didn't cut it particularly square. I used the first plate as a template and turned the piece of steel round, and here I'm cutting the second piece. Note that I didn't cut the piece of steel that was covered in marking out blue, because that's already been cut and I don't think that the edge is square. These plates are slightly longer than they need to be. The dimension of the valve chest is slightly less than the cylinder, but I've cut the plate to the same size as the cylinder. In fact, it's slightly oversized to allow me to trim it to a perfect square edge. Don't write in, I know that the valve chest is the wrong way around. I cleaned up the cut edges on my 4-inch belt sander using my trusty calibrated eye as usual, and here I'm checking the squareness with a set square. And, to be honest, it's square enough, but I think I will do the job properly and put both of these pieces in the milling machine. For this job it is essential that these two pieces of steel are exactly the same size as each other. They are a good match for each other, but I need to use the milling machine to really make sure that they're square. The old milling machine that I use is a drill mill. It's really old. It was made in Korea and it still works very well years later. Here I'm changing the drill chuck for a collet fitted with a 5/16 of an inch diameter end mill. With the parts securely clamped in the machine vise, and I really do mean it securely clamped in the machine vise so they can't move, I take a very fine cut with the milling cutter across the top. I'm not removing much material, but I'm removing just enough to make these two plates exactly the same size as each other. My attempt at squaring off the plates using the belt sander was okay, but this is a lot better. I used the belt sander once again to deburr the edges, and here I'm using an abrasive pad to clean them on the bench. By the way, this stuff is not Scotch-Brite and it's not as good, but it does the job. I'm applying some more steel blue marking out fluid to both of these parts. Like all of my videos, in this video that you're currently watching, I always work out the jobs in my head before I even start the process. And even though in this video I'm showing the fitting of studs to the steam chest covers, which of course are the same as the steam chest, to make sure that they match. If they didn't match, this job would be more difficult. Here, for the camera, I'm verifying that all the studs fit in the holes all the way through both of the steam chest covers. And as you can see, the steam chest cover holes are perfectly in line with each other. This is a good thing. How am I going to approach this? Well, I need to drill some holes in the steel plate. I'm going to stick everything together using Loctite 603. That's both of the plates and one of the steam chest covers. The steam chest cover will just be acting as a drilling jig. Once I've done this, both of the plates then will be exactly the same as each other in every way. And that is it for this episode. Here is a marking out blue drying on the metal plates. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.